Case study 1, TerramEarth. It's a mining and farming heavy equipment manufacturing company. Uh, this was not my preferred case study to start, all these iterations. Earlier, I had Jancomart is my preferred case study, but I think start of 2019 they removed the case study from the syllabus, so we are not going in details for the Jancomart, even though I have this particular case study as additional information for you guys to understand. But yeah, and it contains everything which I would want to actually explain it to you, but it is there in the end of this particular section. So just go ahead and understand what is TerramEarth and what they have given. These case study documents are already given by Google. So before you go to exam, you need to make sure that you understand it and you understand even the solution, right, before you are heading towards the exam certifications. Company overview: manufacturer of heavy equipment for agriculture around 20% and mining around 80%, with 500 dealers and 100 countries since 1946. There are over 20 million TerramEarth vehicles in operations that collect 120 field of data per second. Data is stored locally on the vehicle and can be accessed for analysis when the vehicle is serviced. The data is downloaded via maintenance port. This is the same port can be used to adjust operational parameters, allowing the vehicle to be upgraded in the field with a new computing module. Approximately 200,000 vehicles are connected to cellular network, allowing TerramEarth to collect data directly at the rate of 120 fields of data per second, with 22 hours of operations per day. And TerramEarth collect total about 9 terabytes of data for these connected vehicles. So you need to understand, the size of this particular data, and then while you are providing the solution, you need to make sure that the proposed solution is capable of handling that particular data. Problem statement: this is again given by the company. TerramEarth existing architecture is comprised of Linux-based system that resides in the data center. This system GGF CSV files from the field and upload it via FTP. Terram transform and aggregate them and place the data in their data warehouse. So there is it takes the data in CSV format as a zip, and then FTP to the servers. Those are like Linux based servers, and then there is a ETL machine which runs and then take the data and put that into data warehouses. Because this process takes time, aggregation reports are based on the data which is like 3 weeks old. So it is like the data is almost stale, right? With that data, TerramEarth has been able to preemptively stock replacement parts and reduce unplanned downtime for around 60% of the vehicle. So they are able to fix the vehicle very quickly based on that particular data. However, because the data is stale, some of the customers are without their vehicle for up to 4 weeks because they have to procure it, and ship it, and then once it is available, then they need to plan to replace that particular part. So the requirement is, or I would say business requirement is, to decrease the unplanned vehicle downtime to less than 1 week without increasing the cost of carrying surplus inventory. Support the dealer network with more data on how the customer use their equipment to better position the new products and the services. Have the ability to partner with the different companies and especially with the seed fertilizer suppliers in the fast growing agriculture business to create compelling joint offering for their customers. So the first part, if you look at the business requirement, that is hitting the current problem statement. So the data is very old. They are not able to process the data very quickly because of the size, and they want some mechanism which can process the data within a week's period, right? So that is the requirement. The second one is, that is where improvement part. Around 40% of their customers are like not happy with the current process because they don't get the service on time, or they don't get the product shipped on time, or they don't even know whether there is a problem into their machines going forward. And all of this particular point number 2, you need think differently, and we'll talk about that, how you can think differently. And this is the additional things which you can do it if at all you are offered to do it, right? So that is the additional requirement. Some of the statements that we have it, CEO statement, we have been successful capitalizing on the trend towards larger vehicle to increase the productivity of our customer. Technological changes are occurring rapidly. TerramEarth has taken advantage of connected device technology to provide customers with better services such as intelligent farming equipment. With this technology, we have been able to increase the farmer's yield by 25% by using past trends to adjust how the vehicle operate. These advances have led to the rapid growth of our agriculture product line, which we expect to generate around 50% revenue by 2020. And this is one example wherein they are saying that current the contribution for those numbers are 50%, 20%, and then they are expecting it to grow by 2020. And I think Google may have changed this year as well to 2022 or something like that, because this was there since 3 years now. So what CEO was saying is they are looking at enhancement, growth in agriculture products, and that is he's looking at the overall business prospect. CTO statement from the technology side, our competitive advantage has always been in manufacturing process, which with our ability to build better vehicles for lower cost than our competitors. However, the new products with different approaches are constantly being developed, even by them as well as by their competitors. And I'm concerned that we lack skills to undergo the next wave of transformation in our industry. Unfortunately, the CEO doesn't take technology obsolescence seriously, and he considers many new companies in the industry to be niche player. My goal is to build our skill while addressing immediate market needs through incremental innovations, and this is very, very good statement. So you need to support the existing business model, you need to fix the existing problems, but at the same time you need to make sure that you are innovative enough so that you can tackle the industry competitions, say after 5 years or 6 years, right, or 10 years down the line. If you look at what is that, as we understand, so we understand that there are connected devices, or even if they are not connected devices, when the vehicle is serviced at the service station, they download the data, and then ultimately that data is used to process and massage and understand the vehicle health. I would say first vehicle health, understand, getting to know more about the vehicle, and then if at all there are some parameters or there is a continuous trend for some sensors going down, and then ultimately some of the parts are going down, they are doing that analysis in advance, and they are keeping or storing the inventory of that particular parts in advance, and they are satisfying around 60% of their requirement. This is their current current stack, as because it takes up to 3 weeks to process and ultimately get the sense out of that particular data. There are around 40% of their customers are like without the vehicle, or the vehicles are not getting maintenance properly. Okay, so these are the thoughts around the current problems and the current infrastructure. You need to understand, in nutshell, there are connected devices which are going to go rise, and it will be flooded with the huge information. Currently it is 9 terabytes per I think per 2 days, but that is going to go increase on the load. So you need to make sure that you are designing the solutions which will be scalable enough to tackle with all those connected device by 2020 or 2022. So you need to make sure that you choose it wisely. So understanding as is infrastructure, no hardware specification was given anywhere, but we have the size, we have number of vehicles which will be connected and sent the data, around 120 fields for 22 hours and 9 terabytes per day. Weekly it is going to be like 63 terabytes of data, and aggregated, if you reduce it to 5% of its total data, and this is an assumption. So once you aggregate the data together, you do not need to store the raw data, right? Probably you can go ahead and analyze it more, but once that data is processed, weekly data is processed, then onwards you do not probably need the 2 weeks or 3 weeks 63 terabytes as a raw data. You will use aggregated data, and you can store that data, and then you can use it, and you can back the remaining 63 terabytes into some cold storage, and you can use it afterwards, right, if at all it is required. Major problem which we see here is the long time to process the data, which is like 3 weeks to generate the report. 40% of customer have to wait. Additional connected machines is going to add additional load onto the system, and currently it is hard to manage. Bottleneck with the current process, and not enabling company to put additional analytics on to burden the existing resources, right? So in nutshell, increase the speed of data. That is our requirement. Almost no data loss, machine learning to predict the fault and efficiency, additional connected vehicles and connected devices in future agriculture to grow by 50%, which means new vehicle can be connected to the system, and although new vehicle will be like connected devices, right, majority of the case. Consider the load increase by 2 times in the future. System should be scalable. Non-connected vehicles to collect the data manually by maintenance port may be limited, and some port can be used by adjust operational parameter. And what this particular statement says, you can't process the data just by streaming it, but you need to make sure that you can take the data in a batch mode as well and process it. So there are different aspects, like one is streaming, and then second one is processing data as in when it is occurs in a batch mode. So what we are going to do is we are going to do a business requirement analysis in the next lecture, but that is overall understanding about the case study, and as we understand as a requirement as such, right? So we'll run through one by one, the section as per the cloud architect syllabus, and then we'll see what is that we can find as a solution for these problems.